Welcome to Module 5, where we learn to evaluate models honestly. Here is the idea that everything else rests on. A model's real job is not to ace the data it studied. It's to do well on data it has never seen before. And there are two ways to get that wrong. Let's see them. Here is some training data. Each white dot is one example we get to learn from. The dots are scattered, but they follow a hidden shape, a real pattern underneath the noise. Our goal is to learn that underlying pattern, not to memorize the exact dots. Our first attempt is a straight line. It's simple, and simple is often good. But look, the real pattern curves, and a straight line just can't bend to follow it. It misses the highs and the lows. This is called underfitting. The model is too simple to capture the pattern, so it's wrong almost everywhere, even on the data it trained on. Now here's a model that's just flexible enough. It's a smooth curve that follows the overall trend. It doesn't pass through every single dot, and that's fine. It ignores the random jitter and tracks the real shape underneath. This is the fit we actually want. Now watch what happens when we make the model too flexible. It bends and wiggles until it passes exactly through every training point. On the training data, its error is 0. Perfect. But it didn't learn the pattern, it memorized the noise. This is called overfitting. The truth comes out the moment we show the model new data it has never seen. These green dots are fresh examples. The smooth curve passes right through them. It generalizes. But the wiggly curve misses badly. Every red line is an error. All that memorizing bought nothing on new data. Here's the telltale sign, side by side. For each model, the blue bar is the error on training data, and the red bar is the error on new data. Underfitting, both bars are high. The model is bad everywhere. A good fit, both bars are low, and close together. Overfitting, the training bar is tiny, but the new data bar is huge. That gap between them is the warning sign to watch for. There's really one knob behind all of this: how complex we let the model be. Turn it too low, on the left, and we underfit. Turn it too high, on the right, and we overfit. The error on new data forms this U shape. Our job is to find the bottom of the U, the sweet spot in the middle where the model is just complex enough. So, 3 things to remember. Underfitting is too simple, bad on everything. Overfitting is too complex, great on training, poor on new data. And the goal is the balanced fit in between. Next, we'll give these two failures their proper names: bias and variance.